Hey there, it's Andre again with your quick tip. That is, let's talk about correlation analysis. What does that mean? Well, correlation analysis simply means which attributes have correlations. So let's say one column is correlated to another column. Let's say we're trying to sell our home and there's two columns. One column is the size of the land that the house is on, and the other column is the size of the house and the floor space. Now, let's say that when we're analyzing our data, we notice that pretty much all houses that have a large land size also have a large floor space size, and they're just correlated. The prices go up the same every time the land increases and every time the floor space increases. In this case, these attributes have high correlation with each other. In this case, we can actually remove this from our analysis or from building our model because it might not affect our model. This gets to our next point of forward-backwards attribute selection. What does this mean? Well, we can try training our model using different techniques. Backward attribute selection essentially says train the model on all the attributes and then slowly start taking away attributes or columns to train your model. Does that affect your model? Does it improve the model? Forward attribute selection is the opposite. Start with just one column when you train the model and keep adding one attribute at a time until you get the accuracy to plateau. That is, if you keep increasing columns, and let's say after the 50th column, all the other attributes that you add just don't improve the model, well, then maybe we might not need it. This idea of correlation analysis, the forward-backward attribute selection, are all ways for us to test our model, reduce our data if we want to, and play with our model instead of just assuming if we include everything will make the model better. That's often not usually the case. All right, back to Daniel.